Hello interwebs, welcome to Let's Fix Computers. This is the Christmas wash, which is the last couple of laptops I've got in before Christmas, where I've got a few tickets left to do and then I'm done. So this is a MacBook Pro A1502. Does not power on. The screen on it is really loose, so there's obviously a lot of loose screws in this. It's got some stains all down it there. You can just see in the light, so it's seen liquid. I haven't got liquid spill in my notes, but there's no prizes for guessing that this has clearly had a spill at some point. Let's plug a charger in and see what it does. And the Paul L. Daniels meter says no. Got about 21 milliamps of current. No green light on the charger. So, no. Okay, looks like it's killed. Let's get the back cover off of this and we'll have a look inside and see if we can spot anything screamingly obvious. Ugh. It's a bit crusty in here. Alright. Yeah, we got tide marks in here. So you can see tide marks on the dust there. Dust is fine, but tide marks show where liquid has been in here. And there's a bunch of just scum on the board over here as well. Oh dear. Yeah, the display connector. Just flip that up. Yeah, the display connector is messed up. This is a bad scene. This is a real bad scene. Let's just disconnect the battery super quick. Battery's all crusty and corroded. Terrible. Okay, let me give you a quick close-up of that. Just doing a quick dirty zoom with the camera, so pardon the noise. So, yeah, you can see we've got corrosion in and around the battery connector here. This isn't a big deal, you know, like it probably means that the battery is toast, but power shorting out at the battery doesn't destroy the laptop per se. It destroys the battery. But we've got corrosion around here. We've got corrosion around there. And what's most concerning, we've got corrosion all around the display connector there. Yeah, the JTAG connector there is messed up as well. This is a 2015 laptop. It's going to be 10 years old next year. Well, let's see how bad it actually is. It looks bad. It might not be that bad. So, let's take a couple of quick measurements. This is the assessment phase where really, right now, I'm just asking myself, am I even going to bother with what's going to be a fair amount of repair on a 9-year-old laptop? You know, don't get me wrong, these Retina era laptops, they are, you know, you clean them up and, you know, they're nice enough laptops, but you can't beat the clock, is what I say to customers. You know, it doesn't matter how good a condition it's in. It's still nearly a decade old and has decade-old technology in it. You know, the 8 gigs of RAM is probably just about holding on, but it's a dual-core processor in this. You know, 2 cores, man. You just 2 cores with no modern hardware acceleration of note, which means that if you run a Twitch stream or a YouTube video, the CPU will be sitting at 60% load. You know. Okay, let's get on topic. Black probe on a screw hole. So let's check PP bus G3 hot, which I think is there. Back off and check it again. Okay, no, that's capacitors charging. That's big resistance. That's fine. I assume, well, we don't have a short on the input, otherwise nothing would work. That fuse is okay, and it's not shorted. Yeah, not surprising. I'm going to stab some of the big capacitors around the battery charge area here. 50 kilo ohms. Battery charger inductor 125. I'll let go and stab it again. Yeah, there we go. That's fine. Nearly kiloohms. This might be largely cosmetic. Okay. Let's check some secondary rails. 5-volt rail. Okay. 5 VSB. Okay. Whatever that one is, I can't remember. No, that's okay. Well, I'm not seeing any short circuits per se. I'm just kind of stabbing random big capacitors at the moment, just looking for any screamingly obvious issues. This might be a throw it in the ultrasonic job. In which case, sure. The display connector is the biggest concern. Let's just bring the microscope in. Yeah, so you can see this area down here looks pretty crusty. Where's the backlight? Which end is that at? Backlight is down there, unless I'm mistaken, because you can see we've got a whole bunch of pins common together. Let's just check if the backlight rail is shorted. Which it isn't. And I'm just going to gently just toothbrush that just to see how bad it is. We might have a disaster on the bottom of the board. Like, the board's got to come out if we're actually going to fix this. Just unplug the screen. The connector itself isn't demolished, which is a good sign. If someone's actually tried to run the laptop with an active short circuit on the display connector, that's when this connector itself gets messed up. So the fact that that's okay means that this might not really be as bad as it looks. There we go. That guy's loose. You can see him moving there. So yeah, there's some bad joins down there. That might recover. That might be a touch-up job. Okay, I'm going to run the intro, and we're going to take the logic board out, and we'll have a look at the back of it. And I think I'm going to throw this in the ultrasonic, touch up a few spots, and try my luck. See you after the cut, everyone. So the back of the board looks pretty good. We've got some honest dust here, but there's no corrosion that I can see, which is good news because a lot of the voltage regulators are on the back and those are annoying. So it's just the stuff on the top, and this really does look largely cosmetic if I'm honest. Obviously the only thing that's not cosmetic is the fact that it doesn't start, but that could be entirely down to this JTAG connector. And I'll show you that because I don't think I've done a lot of coverage of this. Let me just bring the microscope back in. So this is the JTAG connector, and it's a diagnostic port. So a actual real Apple technician with all the access to Apple software would plug a magic cable into this and get a full diagnostic readout on a diagnostic machine. And this is kind of important because it's right on the edge of the board where it's really, really vulnerable. And if we look at the schematic for the board on this connector here, we can see that we've got a crap ton of mission critical wires going to it. We've got PP3V42, we've got the SPI lines for the BIOS chip, we've got clock signals, we've got more SPI lines for BIOS. We've got a bunch of stuff going to the SMC. SMC reset L. If this is pulled low, the device doesn't turn on. Just, yeah. So this is a single connector with all of the critical points of failure going to it. Now, if you want to make a diagnostic port, these are the kind of lines that you need going to the diagnostic port. But also, please, engineers, don't put that on the edge of the board where the liquid goes. It is a colossal point of failure that is going to get wrecked if the laptop gets liquid damaged, which is exactly what's happened here. So, like, there's a non-zero chance that if we clean up this connector, it might just go. And you know what? For science, let's just do that. So let's just move the chassis out of the way, and let's just do a little bit of toothbrushing and just see if this board happens to start. It might not because the battery doesn't work and stuff like that. Well, the battery might work. We don't know. Maybe it'll come good. We'll find out. I might ultrasonic this board just for good measure, just to make sure it's actually been properly cleaned, but for now, oh yeah, that display connector still needs a little bit of rework, but like this isn't going to stop it from turning on. This stops it from giving a picture. That's going to need a bit of flux and a touch of the soldering iron to come good. I just want to make sure that there's no shorts there or anything. And you know, we've got some green scum around here, but that, I don't think that's causing any kind of issue at all. Again, just cosmetic. Again, scummy, but not cataclysmic. Okay. So, having just cleaned up that connector so all these lines aren't being shorted together through scum and villainy, let's just connect the motherboard back to the chassis and see if it starts. Louis Rossmann infamously waged all-out war against the JTAG connector and just demolished it off of every board he worked on purely on principle. Because, like, I say that an Apple repair technician would use that, but that's implying that an Apple repair technician would actually fix a motherboard, which they wouldn't. They'll just replace it. So, yeah. Who knows why they even bothered putting it there. Okay, this board needs the battery to be connected, so I'll plug that back in. I don't think I actually need anything else to be connected for it to do something. So, obviously I'll plug the MagSafe connector back in. I'll leave the screen unplugged because right now I just want to see if there's anyone at home, basically. So, let's see what it does. We have a green light. And we have boot. There you go. So, I can't see well, we need to plug everything else in first, actually. So let's not get too excited. However, it lives. Let's plug in. I'll plug in everything else, and we'll just see if it works. My inclination is to fire up the ultrasonic and just ultrasonic this board just for good measure, just to actually clean it properly. Oh, battery. However, technically, a lazier technician than I would probably just send it at this point. Or failing that, you know, if you don't have an ultrasonic cleaner, then that's not an option. But we could just toothbrush all the rest of the board as best we can as well. Of course, if I plug all these wires in and something doesn't work, then we've got other stuff going on. A bad keyboard could shut this whole thing down as well. So if it doesn't start after plugging everything in, we'll start disconnecting things one by one until we get life again. So we've got that loose pin on the display connector. It's probably going to work, but that kind of wants a touch up, just because that kind of thing could cause just the display to just intermittently black out and that kind of thing. So that also needs addressing. Right, battery. Power. And we're going straight up to an amp. Speakers wrecked. Have we got a picture? I didn't plug the SSD back in, so I also need to do that. Actually, I'm going to do that now, just because... go away. An SSD can stop it from starting up. Adamant IT. Hey, look at that. We get a picture as well. And the keyboard also works, which is good. All right. This thing's salvageable. Cool. So this laptop is fine, but it's going to need some actual real cleaning up. Otherwise, it's just going to conk out again in a week or a month. Who knows? So I'm going to warm up the ultrasonic cleaner. I'm going to touch up that display connector, throw the board in the ultrasonic cleaner, and then just basically clean this thing up and just try and make it as nice as I can. And I think this is probably one of those, like, this is what I would call a last service kind of thing. Like, this is the last time we're going to bother giving this thing any kind of love. Left speaker is shot. I might have a look. I might, if I've got a spare one, we'll change that out. But you've got to be we've got to tighten the hinges as well. But you have to be a little bit careful when working on old laptops like this, because the more you work on them, the more stuff you find wrong with it. And it's just never ending, you know. So yeah, we've got to be a little bit careful. But you know what? If it works, the customer still uses it. It's still useful to them. We'll give it one last shot. So I'm going to take stuff out and let's do a little bit of a cleaning montage. There we go, just a quick flux and reflow on those pins there. Didn't need to add any solder at all. Didn't need to remove the connector. Just a little bit of a touch-up is all that was needed there. We had a picture out of the laptop already, so arguably this wasn't necessary, but you saw that pin move. If we're going to bother cleaning this thing up, we may as well have just touched up that joint while we're here. The speakers on these are pretty easy to get to, especially on the 13-inch like this. We've just got 3 screws that come out, and then this guy will just pull out like that. And this guy here... Well, I don't see a torn cone, but it doesn't feel right. It looks like it almost feels like the driver is like pressed in. There's no bounce on it like there should be. So either way, that's going to be our culprit there. I'll just see if I've got any of these kicking around in a breaker laptop or something. There we go. I've given the chassis a clean up. The screen is a little bit of a mess. It's got the signature anti-glare coat wear and tear on it. I once said in a video that there wasn't a whole lot you could do about that, and that's not entirely true. You can get compounds which will just effectively just scrub off the last of the anti-glare coating. It's not something I've ever done myself, but I know they're out there and they do exist. I'm not going to put that much time into this one because, yeah, if this was like a touch bar or something like that, that's probably worth doing. But we've got to we need to avoid scope creep in this. So, right, we've cleaned up the chassis. The motherboard is ready to go in the ultrasonic cleaner. So let's give that a dunk, and then we should be ready to reassemble this thing again. Right, folks, welcome to the wide-angle zone and my insulation to make it heat up quicker. Ugh. It's just... Ow! Oh, it's hot! Ow! Oh, it's very hot. I don't show this thing off very often. This is a Vivor unit. It's like 20 litres. It's huge. Because at some point I said that I wanted an ultrasonic that was big enough to put like an ATX motherboard into, which this is. And one of my patrons very kindly bought this for me. So it's kind of overkill for laptop stuff. However, it is nice having something that's big enough to put anything in. Water's a little bit murky at the moment because I cleaned a really grossy motherboard in it the other day. But at any rate, here we go. So I've got it at 50 degrees at the moment. The solution in there is deionized water mixed with a just generic electronics flux cleaning solution. So it gets a little bit soapy when it gets mixed up. So I'll just drop that guy straight in there and I'm going to hit the go button. So we're at 50 degrees, I'm going to give it 4 minutes, then I'll flip the board and give it another 4 minutes. Here we go. Changeover time. Starting to look shiny already, although it's not difficult to do that when the whole thing is dripping wet. Slowly, so it doesn't float away. I can hear the phone going in the other room. See you in a minute, folks. Okay, that's our other side done. Come on, stop dripping. Okay, so now the process I'm going to go through this is I'll give it a quick drip dry, just to overbalance it and drop it into the pool again. Then what I'll do with this next is I'll use my air duster to blow all of the water off of it. Then I douse it in isopropyl alcohol and blow all the alcohol off. This should drive all of the water off of the board and out from under the BGA chips, which is the main objective. One thing that I don't do yet, which I want to start doing in the new year, is to get a small oven in here, like an easy bake oven, that kind of thing. And what you do is you stick the board in the oven at like 100 degrees C for, I don't know, an hour or something like that. 100 degrees isn't enough to cook or melt anything, but it drives out all the moisture and actually dries the board properly. Now, I haven't done this and it hasn't been an issue yet, but it is technically something that should be done. So I'm just making people aware that that's the correct way to do it. But for now, I'm just going to do the blow dry alcohol rinse and then blow dry again. And here is the end result of that. So the board is now shiny and clean. Looks like it came out the factory yesterday. Obviously, all of the water sensors are all bright red now, but, you know, we're kind of past the point of caring about that. I'll just bring in the microscope so I can show you those trouble spots and you can see how nice and shiny those all are now. So if we have a look here, starting at the battery connector, you can see that's now nice and cleaned up. We've got rid of all of the schmutz that was just under there. And those green spots that were around that MOSFET and over near these capacitors, that's all gone. That's all shiny and clean. And if we come down to the display connector, you can see that that's all looking fine as well. Those vias don't look great, I'll give you that, but they're intact and now they've actually been washed out. We've washed the corrosion out of those and time will tell. A lot of experts in the field say that once a board has suffered corrosion like this, it will never truly be okay again. However, at the end of the day, we don't care if this board lasts 10 years. Realistically, it just needs to last another year or two or whatever. And if it conks out, then it conks out. However, for the time being, we've given it the best chance of continuing to work. And we've actually made sure that all of those bits of corrosion that had been actually causing an issue, that has all been removed. So we've given it its best chance now at this point. So if we wanted to go further, I mean, I don't know. We've already gone over those solder joints there. I don't think there's a lot we can do about those vias. I don't know if you can go at those with a soldering iron and like re-tin them or not. I'm not going to try. I'm going to quit while I'm ahead personally, on the assumption that the board works, obviously. But yeah, those vias are going to internal layers on the board. So I'm going to leave well alone, and I'm going to commit with what we've got, which is a nice clean board. Okay, right, time to ruin my Christmas and find that I killed it in the ultrasonic. We have power, and we have power draw. And we have a chime. Wonderful. That chime wasn't horribly muffled and garbled as well, which is a good sign. No picture found. Okay. Right. I'm going to take a stab in the dark and assume that it's those dodgy looking vias that we saw. At this point, it's very easy to look at that and be like, cool, you killed it in the ultrasonic. Good job. But consider the fact that my rationale is always, if the board can't survive the ultrasonic, then it wasn't going to survive anyway. If something is so weak that it's going to break in the ultrasonic cleaner, then it was not sound as it was. So the last time we checked on this was when we had corrosion and a pin that was hanging off on the connector. That's something that could have gone at any moment. To be honest, I'm amazed that the screen worked in the first place. So, sure, we have regressed slightly, but we're not going to panic. We're going to have another look at those vias and see if we can do anything with them. So first of all, earlier on I said that the backlight lines were probably down here, and I'm not quite right. That is power to the LCD, but it's not the backlight rail. I don't think so. No, it's not. Because if we come up here, pin 1 specifically says it's the backlight. I'm surprised. I thought that there would be more pins for the backlight. Whatever. It doesn't matter. Either way, when we look at the board itself, this is where some of our problem vias are. So I've just gone into continuity mode. The battery is disconnected. I'm just going to see if I've got continuity onto... Is the pin on, firstly? Yeah, it is. Okay. So, can we get a beep into those vias? Yeah. Now, those... Let's see where that connects to. If we look at the board view, that jumps over to here, to these capacitors here. So we can check if we've got a connection over to those capacitors to see if those vias are actually intact or not. So let's try that. So I'll put my black probe on that pin, and my red probe is going to check these capacitors up here, which are apparently to do with the backlight. I'll keep the microscope down here, just because that's where I need to be able to see. Yes. So we're getting continuity. Yeah, so I think the beep comes through the microphone. At any rate, I'm getting continuity from that pin to those capacitors. So we know that those vias are okay, because we've got continuity through them. So the next couple of pins, going back to the board view, we've got no connection here to separate the backlight rail from important stuff. Imagine doing that. Apple used to have some kind of common sense. Then we've got we've got no connection. Then we've got 3 pins. Then the next 4 pin, 1, 2, 3, 4. This one here is then going into a via that looks sketchy. So that pin there is SM bus SMC SCL. So that's a serial clock connection. And if we have a look on the board, this is the one that then has another really terrible looking via on it. So I'll try and probe that, just see what happens. I'm getting beeps there. Now, is there any chance of finding a test point that connects to? Let's look on the board view. So that goes back to the SMC. Ah, there's a resistor there. So we can check if it links to that resistor. Ah, the problem is, though, that's on the other side of the board, which I can't get to right now because the laptop is open. There is, however, a test point there, which might be good enough. No, there isn't, because it's not on this side of the board. Okay. That's a problem. Right. Let's take a closer look at that via. Okay, let's do just a little bit of scraping on these. I know I said these vias are okay, but I think what I'm going to do is just run the soldering iron over them just to tin them. And that will just arrest that rust that's forming on them. So I'm just going to gently keep scraping down to this until I can hit some metal. Okay, I think I'm butchering this. I'm going to stick some solder on that and send it. At this point, my confidence kinda tanked because I knew I was going to need my J-tip to fix this, and my J-tip is completely toast and it doesn't take solder. It's why I stubbornly continue to use my knife edge even when it's a bit too big for the job. So I'm going to speed through this section. I know it's ugly, you don't need to tell me, but after a lot of struggle I managed to get a protective solder blob attached to the via, and I called it quits there. The pro gamer move would also have been to thread some enamel wire through that via and solder it on the other side of the board, thus creating a brand new wire through the hole. However, after I got my solder blob attached, I decided to quit while I was ahead. In the new year, I'm going to replace this J-tip with a nice JBC one that'll fit my Aixon T3B soldering iron, and that should solve this problem going forward, so then people can stop shouting at me about my soldering iron tip. It's not that I don't clean them, it's just knackered. And it's booted up just fine, so we're all finished now, or at least the video is finished now. I'm going to need to do a software service on this. It wants a macOS update and stuff like that, but the laptop survives, so it can plod along for as long as it remains useful to the customer. The customer's going to say to me, how long do you think it will last? To which I will say, until it's no longer doing what you need it to do. I mean, in my opinion, this laptop is already end of life and should be replaced as soon as reasonably possible. You know, I would go and buy a MacBook Air M1 secondhand. You can find them on eBay for between £350 and £400. And I think that's cracking good value for money right now. I tend to buy those in and resell them in my shop as replacements for laptops like this. However, if the customer just wants to check their email and just wants to use Facebook Messenger, it's still going to be able to do that. Or failing that, if it gets handed on to a kid doing their homework who doesn't need high performance and just needs an old laptop where it doesn't matter if they drop it, well, it's good for that as well. Anyway, have a lovely Christmas, everyone, and thank you, as always, to all of my supporters. So the Patreons, the channel members, my Twitch subscribers, and, of course, you, the average viewer. Catchphrase. I'm leaving it in. Thanks for watching, everyone. I'll see you soon. Bye.